Hello again. Let's work on cost minimization over a Leontief function. Assume the Leontief utility function is fixed at 100, meaning we have 100 equals min of 2x, 0.5y. Assume the budget line is expenditure or sum budget equal 1x plus 2y. The price of good X is 1 and the price of good Y is 2, right? Here are our tasks for this video. We are going to find the optimal bundle of good X and good Y. We'll find the minimum expenditure and we'll find the total marginal cost of increasing utility from 100 to 101. And then we'll have the item 4 graphing. So what math skills do you need in here? Well, partial derivatives, college algebra, and graphing skills. Let's jump in. I did a bit of the work so that this goes fast. You have the Lagrangian function. We write that portion of the budget line, x plus 2y, and then we have the two constraints in there. Okay, we will have the first order conditions next. Now, if you need a review over how power rule works, please refer to the other video that I will link in the description box. So we need to take the derivative of the Lagrangian function with respect to x, with respect to y, with respect to lambda 1 and lambda 2. Now, that first equation, now try to use a different color here. That first equation, d Lagrangian dx, well, the derivative of x with respect to x is just 1 minus lambda 1, 2. Now, another x is found only in this second portion, right? And not in the third portion. So the derivative of that with respect to x will be lambda 1, 2. Set that equal to 0. Derivative of the Lagrangian function with respect to y is 2, right? So 2 minus another place where y is in that third part. So lambda 2 minus 0.5 lambda 2 equals 0. Then we take the derivative of the entire Lagrangian function with respect to the first constraint, lambda 1, well, the constraint on good x. We just write the stuff in the within the curly bracket of that second part. The derivative of the entire Lagrangian function with respect to the second constraint over good x, good y, is the part within the curly bracket. Again, if you need a review on how power rule works, you want to look at the video I have linked in the description box. Okay. From the first equation, we make lambda 1 the subject such that lambda 1 equals a half. From the second equation, we make lambda 2 the subject such that it is equal to 4. And this is where your college algebra should kick in, right? From the third equation, we will make x the subject such that 2x equals 100, x is 50. From the fourth equation, we'll make y the subject such that 100 equals 0.5y, y is 200. Take a minute and check my math and see if you can arrive at these answers yourself. Now, from equations 3 and 4, we have the optimal bundles, x equals 50, y equals 200, to find the minimum cost that allows us to hit 100 in utility. We plug these two into the expenditure or the budget line, right? So 1x plus 2y, 1 times 50 plus 2 times 200. The answer is $450. Cool. What's next? Well, we want to find the total marginal cost of increasing utility from 100 to 101. If I were to expand my level of satisfaction by just 1 unit, how much would I need? Right? So what's the marginal cost I will incur to gain more satisfaction? And that satisfaction is just by a unit. So from 100 to 101. Now, we have to look at this for the 2x good. For the 2x good, that lambda 1 was 1/2. Well, but that's equal to 50 cents. What does this mean? And how many units of good X can we buy with this 50 cents? Well, the price of good X is $1 per unit. And so if I have 50 cents, I can just buy half an extra unit of good X, right? So I'll buy one half of an extra unit of good X. Good. Now, the marginal cost of increasing utility from 100 to 101 for the 0.5y good, well, that lambda 2 is equal to $4. Now, how many units of good Y does that buy? Well, the price of good Y is $2 per unit. And so with $4, I can buy 2 extra units of good Y. When I sum that up, when I sum up the marginal costs, I can get 0.5 plus $4 is $450 as the marginal cost it will take to increase my utility or my satisfaction from 100 to 101. From here, we are going to graph our answers. So I tabulated here, and let me change my pen to red color. I tabulated here in red all that we've calculated, right? The minimum total expenditure, that's $450, the optimal quantity of good X, 50 units, optimal quantity of good Y, 200 units, and the utility level at 100. So we were given in the question the utility function, and we were given the budget line as expenditure equals X plus 2Y. But because we have found the minimum cost or the minimum expense that gets us to 100 in utility, we have rewritten that budget or expenditure line as 450 equal X plus 2Y. That allows us to draw it. So to draw it, we first need to identify the end point along the vertical axis and the end point along the horizontal axis, and then connect them with a straight line, which is what I did, but let me walk you through that. So to draw and connect the end point, well, I first have to imagine that if X is 0, or if X were 0, Y equal 450 divided by 2, so that I have my intercept at 2 to 5. And so that's why I have 2 to 5 here. And then I can imagine if Y were 0, what would X be? If Y were 0 along the horizontal axis, X would just be 450. And so that's why I have 450 over here along the horizontal axis. Am I done? No. I can locate the optimal bundle along that budget line. The optimal bundle was 50 units of good X and 200 units of good Y, and I have them nicely labeled on the budget line. Now, I do know that this is occurring at tangency where my indifference curve is just tangent to my budget line. I talk a lot about tangency and indifference curves in other videos. I will link them in the description box too, so that you can have more fun with it. But we are just trying to get through this assignment and box on, right? Okay, so how do you draw the L-shaped indifference curve, also known as the Leontief indifference curve? Well, the way you do it is You take you take that utility function, and you notice that it's min parenthesis or curly brackets 2x comma 0.5y. So equal to 100. This means we are going to select the minimum out of that. Now, the way you do it with this is, well, let's say that 2x equals 100. So x equals 50, x equals 100 divided by 2, right? So x equals 50 is the minimum, right? That is the minimum if the other term within the curly bracket is greater than or equal to 100, right? If I gave you for example, right, let's do a little detour, and I realize I'm drawing it where I should be drawing the other things, but this is a little detour. If I gave you this detour, right, and I said min x, y. Now, if you choose x as the minimum, pardon me, if you choose x as the minimum, that just means that y was not chosen because y was equal to x or larger. The other thing was larger than what you selected as the minimum. Now, if I okay, x is selected if y is as big as or bigger than x. You see? Okay, let's get rid of this. In that same spirit, right, if you choose given 100 equal min curly bracket 2x comma 0.5y, if you choose 2x equals 100, that means that the other thing was bigger than 100 or equal to 100. So that's what I have written out here. Now I have to follow through and find out what y is when x equals 50 is the mean. Well, y is the other thing. 0.5y is greater than or equal to 100. So we find out that y is greater than or equal to 200. What does this help us do? This helps us draw the vertical portion of the indifference curve, right? So helps us draw vertical portion of indifference curve, of the L-shaped indifference curve. Okay, and can I draw it? Yes, of course I can. I can draw it. So from the vertex, I just extend my line up, right? See how where y is equal to 200, x is 50, right? X is 50. Where y is equal to 200, x is 50. And where y is greater than 200, x is still 50. So that's the vertical portion of my Leontief or L-shaped indifference curve. I have the horizontal portion coming next. So for the horizontal portion, the other thing now, 0.5y now, right, equal 100. So y equals 200 is the minimum. And, well, that holds if the other thing within the curly brackets 2x is greater than or equal to 100, such that x is greater than or equal to 50. So this helps us draw the horizontal part of the indifference curve. Okay. Such that, well, when y is 200, x is equal to 50, but as x gets bigger than 50, well, y is still 200. That's the L shape, and I will have u oops. Let's use a pen here. And I will have U equal 100. When X is 50, Y is 200. When X gets bigger than 50 this way, Y is still 200. And so we extend that horizontal leg of the indifference curve. And that's how to draw the Leontief indifference curve. Are we done? No. One more thing. Okay. So I went ahead. If you notice, I have some stuff in blue here. Let's go over it so that I show you what other thing I did. You remember that the total marginal cost it takes to go from 100 utility level to 101 utility level was $450. Okay, when I add that to the minimum expenditure that we already calculated in red, I get changing the color to blue now. I get $454.50. Okay, and if you remember earlier on, I told you that with the additional 50 cents, I can purchase another 0.5 extra units of good X. Well, I added it to the 50 units of good X that we calculated as the optimal quantity of good X. Well, so that is now 50.5 units. And then when we calculated the marginal cost of increasing utility from 100 to 101 for the 0.5 Y good, right? We found out that we can buy 2 extra units of good Y. So that 2 extra units plus the 200 optimal quantity, that is 202. And that utility level that we hit is 101. What am I doing? What I am doing is drawing a new budget set. Why? Well, knowing that the total marginal cost it takes or I have to incur to go from 100 utility to 101 is $4.50. I add that to my $450 minimum expenditure or minimum cost that I calculated, right? So that now I can write my new budget set or budget line as this, equal X plus 2Y. And using this equation, I drew the blue budget line. Now, what about the indifference curve? Do I get a new utility? Yes, it's 101 equal min 2x 0.5y. But from the table and the things in blue in the explanation I have given you, you can see that it will give us 50.5 and 202 as the new optimal bundle on the tangency between the indifference curve with the utility 101 and the new budget line in blue, all drawn in blue in the new graph. And so what does this mean really? Well, what this means is that, or what we can conclude from this last graph is that it will seem that the consumer prefers bundle B to bundle A, right? It will seem that the consumer is indifferent between bundles B and C. Yeah, why would a consumer be indifferent between bundles B and C? Because bundles B and C will give the consumer the same level of utility, 101, right? So this is just concluding and trying to interpret what the points are. I made the point C up, right? But points A and B are what we just calculated. Point C is totally made up. It's made up to test our our knowledge if we understand the relationship among these three bundles A, B, and C. Okay, and I will stop here. Have a good one. Dr. T out.